learning something and thought, when am I ever going to use this in real life? So, you're telling me I'll need trigonometry to buy groceries? Well, probably not. But what if I told you that there is a way to learn that actually makes sense? And that is what we call context-based learning. What is context-based learning? Let's find out. Context-based learning utilizes real-life and fictitious examples in teaching environment in order to learn through the actual practical experiences. So, instead of simply learning calculations and formulas, you also understand why you need them in the first place and how they'll be used in real life. Theory, of course, is important, and everyone can start from there. But the real magic happens when you put things into practice and in context. Context-based learning works because it taps into how our brain loves connections. When we link knowledge to the real experiences, we remember it better and understand it deeper. Think about it. Do you remember more from a dry lecture or from a hands-on field trip? Here are the steps in using the context-based learning. First, identify learning objectives. You have to clearly define what students need to learn and how it applies to real-world situations. Number 2, design real-world context. Develop scenarios or problems that reflect everyday challenges related to the subject matter. Number 3, develop learning activities. You have to create tasks that require students to apply their knowledge within the context, such as projects, experiments, or simulations. Number 4, facilitate active learning. Encourage students to engage actively through discussions, collaborations, and hands-on experiences. And number 5, assess application of knowledge. Use assessments that measure how well a student can transfer and apply the learning to the real-world context. What are the key characteristics of context-based learning? Context-based learning connects academic concepts to real-life situations, making the learning more meaningful and engaging. It emphasizes real-world relevance, active learning, and problem-based approach to develop critical thinking skills. CBL is learner-centered. It encourages collaboration and integrates technology for enhanced engagement. It also promotes self-assessment, flexibility, and authentic assessment, ensuring that the students apply knowledge in practical concepts. This approach prepares the learner for real-life challenges and making education dynamic and applicable. So here are the ways to apply context-based learning. First, real-world scenarios and case studies. Instead of just explaining a topic, tell a real-life story that relates to it. Example, if you are teaching about climate change, talk about how extreme weather has affected a nearby town. Why it works. The students relate better to our real situations and remember them longer. Number 2, problem-based learning or PBL. So instead of just memorizing facts, let students involve and solve problems based on real-life situations. Like for example, in a math class, instead of just giving an equation, ask students to plan a family budget or calculate costs for a school trip. Why does it work? Students feel engaged because they see how math is useful in daily life. How does context-based learning help students develop a critical thinking and problem-solving skills? Context-based learning develops critical thinking and problem-solving skills by engaging the students in real-world challenges that requires analysis, decision-making, and application of knowledge. It encourages the students to evaluate perspectives, identify patterns, and develop multiple solutions rather than relying on memorization. Through collaborative discussions and hands-on problem solving, students refine their reasoning, adapt to challenges, and build confidence in decision making. This approach makes learning dynamic, fostering independent thinking and practical problem-solving skills that is essential for real-life situations. What are the challenges of implementing this strategy in an integrated science classroom? Using context-based learning, or CBL, in an integrated science classroom can be challenging. Lack of lab resources, equipments, and technology can make hands-on activities difficult. Also, time limits make it hard to fit the real-world projects into the school schedule. The teachers need extra time preparation to design engaging lessons, and some students may struggle with solving open-ended problems instead of memorizing facts. Grading can be tricky too, as real-world projects takes longer to assess than regular tests. Also, combining different science subjects and arranging real-life experiences can be difficult to manage. However, with good planning and creativity, the teachers can overcome these challenges and making science more exciting and relevant to the students. How does context-based learning align with the K-12 science curriculum and most essential learning competencies, or MELCs? The context-based learning, or CBL, aligns with the K-12 science curriculum and most essential learning competencies, or MELCs, by making subjects like math and science practical and relevant to everyday life. It supports inquiry-based learning, problem-solving, and critical thinking, which are the key goals of our curriculum. Can this strategy be combined with other approaches for better learning outcomes? How? Yes, context-based learning works even better when combined with other strategies. For example, pairing it with problem-based learning lets the students solve real-world math problems, like planning a budget using algebra. Inquiry-based learning encourages them to explore and analyze real data, such as survey results in statistics. Collaborative learning makes math more engaging by having students work like in teams, like designing a house plan using geometry. Also, adding technology like graphing apps helps students visualize concepts, while differentiated instructions ensure that every learner gets the support they need. By blending context-based learning with these approaches, math becomes more practical, engaging, and easier to understand, helping the students see its real-life value. How does this strategy cater to different learning styles, like visual, auditory, and kinesthetic? Context-based learning supports different learning styles by making math more engaging and relatable. Visual learners benefit from graphs, charts, and real-world diagrams like using geometry to design a blueprint. Auditory learners grasp concepts through discussions, group problem-solving, and explaining their reasoning aloud. While kinesthetic learners thrive with hands-on activities such as measuring objects for a lesson on perimeter or experimenting with budgeting in real-world scenario. By presenting math in different ways, context-based learning ensures that every student can connect with the subject in a way that makes sense to them by making learning more meaningful and enjoyable. How can teachers assess student learning effectively using this strategy? Teachers can assess student learning and context-based learning by focusing on real-world applications rather than just tests. Instead of memorizing formulas, students can present projects like creating a business budget or analyzing a survey data to show their understanding. Hands-on tasks such as designing a floor plan or solving a real-life math problem let the teachers see how well the students apply the concepts. Group discussions and reflections help assess students in their critical thinking, while self-assessments encourage students to track their own progress. By using practical, engaging assessments, teachers get a clearer picture of what the students truly understand and how they use math and other subjects in real life. I hope you learned something about the context-based learning. But before I end this video, let me leave to you a quote by Benjamin Franklin. Tell me and I forget. Teach me and I may remember. Involve me and I learn. That would be all. Thank you for listening.